Hello, everyone. Good morning. Welcome back. I'm Steve,
And I'm Scott.
and together we are Backyard Musings. I'm in Apple Valley, California.
And I'm still in Utah for a couple more days.
Okay,
And we're talking
physicists,
we're talking science and technology.
yes, sir. Physicists have discovered a never before seen atomic nucleus, aluminum 20, that quite literally falls apart in three distinct proton bursts. This rare and unstable isotope doesn't just decay, it unravels through a dramatic sequence of proton emissions that challenge long held assumptions about nuclear structure. The finding remarks the first known case of a triple proton decay chain, and it may even hint at a break in the fundamental symmetry of atomic particles, opening a new frontier at the edge of nuclear stability. Would you like to know more?
Radioactive decay is a natural process that occurs when unstable atomic nuclei release energy in the form of radiation. Scientists study how these atoms break down to better understand the behavior and structure of atomic nuclei. Among the more unusual types of decay is proton emission, which allows researchers to investigate rare and unstable nuclei that lie far from the so-called valley of stability, the part of the nuclear chart where stable atoms are found.
In a study published on July 10th in Physical Review Letters, a team of physicists from the Institute of Modern Physics at the Chinese Academy of Scientists, along with international collaborators, announced the first ever detection and analysis of aluminum 20. This previously unknown isotope is highly unstable and decays through an especially rare event known as three-proton emission.
Quote, aluminum 20 is the lightest aluminum isotope that has been discovered so far. Located beyond the proton drip line, it has 7 fewer neutrons than the stable aluminum isotope, said Associate Professor, oh boy, Zhongdong Zhu from IMP, first author of the study. Okay.
To detect this elusive isotope, the team used an in-flight decay method at the fragment separator facility at the GSI Helmholtz Center for Heavy Ion Research in Darmstadt, Germany. By measuring the angular patterns of particles emitted during the decay, they were able to confirm the existence of aluminum 20 and observe its unique breakdown process.
Through detailed analysis of angular correlations, the researchers found that the aluminum 20 ground state first decays by emitting one proton to the intermediate ground state of magnesium 19, followed by subsequent decay of magnesium 19 ground state via simul, simul, simultaneous two proton emission. Aluminum 20 is the first observed three proton emitter, whereas its one proton decay daughter nucleus is a two proton radioactive nucleus.
Oh, that's a mouthful.
Yeah.
The researchers also found that the decay energy of the aluminum 20 ground state is significantly smaller than the predictions inferred from the isospin symmetry, indicating a possible isospin symmetry breaking in aluminum 20 and its mirror partner, neon 20.
This finding is supported by state-of-the-art theoretical calculations that predict that the spin parity of the aluminum 20 ground state differs from the spin parity of the neon 20 ground state. Quote, the study advances our understanding of the proton emission phenomena and provides insights into the structure and decay of nuclei beyond the proton drip line, says Zhu. I don't have any idea what a proton drip line is. I know what a water drip line is, but not a proton.
So. Probably when protons drip off, that's probably just like water drips off. Okay, to date, scientists have discovered over 3,300 nuclides, yet further than 300 are stable and exist naturally. The remainder are unstable nuclides that undergo radioactive decay. Common decay modes such as alpha decay, beta minus decay, beta plus decay, electron capture, gamma radiation, and fission were discovered by the mid-20th century.
I'm sure glad you read that paragraph. Over the past several decades, owing to the tremendous development in nuclear physics experimental facilities, and detection technologies, scientists discovered several exotic decay modes in the study of nuclei far from stability, particularly in neutron deficient nuclei.
In the 1970s, scientists discovered single proton radioactivity where nuclei decay by emitting a proton. After entering the 21st century, two proton radioactivity was found in the decays of some extremely neutron deficient nuclei in recent years. Even rare decay phenomena, such as 3, 4, and 5 proton emission, were observed. So, I mean, if you're from MIT and you listen to this, you probably understand it.
Yeah.
But it's
Okay.
interesting. I mean, I didn't know that aluminum 20's sister was neon 20. I didn't know that. That's cool.
I didn't know that there was an aluminum 20.
We just discovered it.
I
All
thought
right,
there was
folks.
aluminum foil in my kitchen. So
You've got a hat, an aluminum foil hat, right?
yeah, I got one of those too. Yeah.
All right, folks. We'll see you later. Talk to you later.
Take care, everyone. Thanks.